A solar eclipse happens when the moon's shadow falls somewhere on the surface of Earth, and a lunar eclipse is the opposite, when the Earth's shadow falls on the moon. The two sections of the shadow, the dark umbra and the partially shaded penumbra, their placement determines which type of eclipse we can see from Earth. The moon orbits Earth every 29.5 days, but we don't get eclipses every month. That's because the moon's orbit isn't in line with Earth's orbit. It's tilted about 5 degrees. That doesn't seem like much, but keep in mind that the scale of the model we're showing to you is way off. If the Earth and moon are this size, the distance between them should be around 10 feet. At this distance, 5 degrees is enough to keep the moon's shadow off of Earth and the Earth's shadow off the moon most months. So why do we ever get eclipses? Because there are 2 points where the moon's orbit crosses the sun's plane, called nodes. And as the Earth moves along its annual orbit, those points line up with the sun about twice a year. As the moon passes between the sun and Earth at that time, we get a solar eclipse. And when it's behind Earth at that time, we get a lunar eclipse. There are a ton of orbital quirks that make predicting eclipses really complicated, but in general, we'll have a few solar and a few lunar eclipses of some sort every year.
This is the Earth and the moon to scale. If the Earth were this big, the moon would be this big and this far apart.
The sun is 400 times the size of the moon, but it's also 400 times further away. That trick of perspective is why they look the same size in the sky, and why during a total eclipse, the moon covers the sun perfectly.
We have a moon that's just the right size and the right distance away to very neatly block out the sun.
If the moon orbited on the same plane as the Earth and sun, eclipses would happen once a month. But the moon orbits on a tilt.
It's tipped a little more than 5 degrees.
Because of this tilt, it lines up with the sun very rarely.
It's only when the three bodies are in a straight line that an eclipse can occur.
But
we interrupt this video for an important safety announcement. Looking directly at the sun, even during an eclipse, can cause permanent eye damage. Fortunately, there are ways to enjoy an eclipse safely. The easiest is to use certified eclipse watching glasses, which are shaded thousands of times darker than typical sunglasses. You can also look at the eclipse indirectly by making a pinhole viewer. Simply poke a small hole in a piece of cardboard. Hold the cardboard up to the sun, allowing the sun's image to be projected onto a flat surface. Be sure to look only at the surface and not through the cardboard. Just before the moon completely covers the sun, low-lying valleys on the moon's edge will be the only spots that sunlight continues to pass through. These remaining brilliant shafts of light, known as Bailey's beads, will disappear one after another. And finally, a single bead of light remains, known as the diamond ring, signaling that you're just seconds away from experiencing totality. Once the last bead disappears, and the moon completely covers the sun's surface, the view through your eclipse glasses will be pitch black. Totality achieved. At this point, none of the sun's rays are reaching your eyes, and it's the only time that it's safe to take off your glasses. Remember to put your eclipse glasses back on before any of the sun's rays start to peek through again. Any sunlight reaching your eyes, even for a few seconds, can cause serious damage. While an eclipse can last a few hours, totality typically occurs for less than 3 minutes. Animals and plants have also been known to alter their behavior during a total eclipse. Songbirds may stop singing, crickets may start chirping, and flowers may even start to close up.
A total solar eclipse begins as a partial eclipse. You'll notice trees projecting the crescent sun and shadows becoming sharper than normal. The landscape darkens to a bluish gray, and you'll start to feel the temperature drop. From the west, the moon's shadow rushes towards you like a silent storm. Look up and you'll see the last sliver of the sun sparkling like a diamond ring before it's broken into a string of beads by the moon's rough terrain. Now you can see the pearly glow of the sun's corona and the pink and red light from the hydrogen gas of the chromosphere. Together, these make up the sun's outer atmosphere, and a total solar eclipse is the only occasion you have to lay eyes on it. This is totality, and if you get a chance to see it, you should.
Der Chef der Sternwarte mir war super in so einem Moment, Herr Philemon. Super. This is just fantastic.
A lot of early civilizations feared eclipses. They were seen as an attack on the sun or moon by the forces of darkness. But now that we understand our place in space, eclipses are an occasion for awe and for gratitude. All over the galaxy, rocks are casting shadows on other rocks, but only here, as far as we know, is there someone to notice them.